Okay, the next thing I did was just to get an overview of the relationships between pairs of data. In R, I'm going to use a function that I found online. If you've been in my class, you've seen this function before. I'll put a copy on this on my website to make sure you can use that if you want to. But anyway, since I have a new variable in there, it turned out the easiest thing for me to do was to create that variable in Excel. In other words, detach this data set I had, recreate the data set in Excel, and just get that variable, and then read the new data set before I did the plots and so on. Anyway, so you can see here I have detached car seats, then my data is reread the file that I had in Excel, and that file basically looks like our data there, and you can see that I have a column added here that is just price, which is G2 minus C2, which is the competitor's price. And so I have this file out here named car seats, and so my data equals that, and then I'm going to attach my data. Now the function that I'm talking about, you have to first of all create a a new data set that just has the variables that you want to use in the function. And so my variables equals, and then I've got sales, competitor's price, price difference, and so on in here. And I could have added urban and US, but I've decided already I'm not going to include those in my final analysis. So anyway, just to get an overview of the data here, I did that, and it's my new data is equal to my data, the name of my data set, and then in brackets my variables. And so that's one thing you do have to change anytime you use this. So you have to run that. Then the function starts here, and you just have to highlight all of this and run it once in this data set down to right here. This is the end of the function when you have that curly bracket there. And then after that, the only thing you have to do is make sure that this is the same name, new data, that I just called my new data set. And if you do all of that, then you can just run all of this, and you will end up with this. It has scatter plots, histograms for each variable, and then a correlation matrix with confidence intervals. It'll be a little bit hard to see things because there's so many of them. It's kind of small there, and I couldn't zoom in for some reason on this, so I just copied this over into Word, and I'll bring that over here and just quickly go through here some things that we want to look at. Our response variable sales, we would like to have that correlated with some of the things here. It looks like it has a negative correlation with our price. That makes sense. Negative correlation with price difference, even higher. Then income, competitor's price, by the way, it wasn't that correlated with. Advertising, a correlation of 0.27. Doesn't look like it's that correlated with population. Negative correlation to age. Not much of a correlation with education. And then with shelf location, 0.16. I guess a moderate correlation, or a small correlation anyway. Then the other thing to look at while you have all these up here is the rest of this diagonal here gives you the correlation for your explanatory variable between explanatory variables, and what you like to make sure is that none of those are too highly correlated. A cutoff a lot of people use is 0.7, so I'm just scanning through here at the correlations, and I don't. Now there's one, price difference and price. Of course, you wouldn't want to include both of those in the same model. Price and price difference are included. Price difference is computed as a function of price, so you wouldn't want to include both of those. And then looking through here, I don't see any other real problems or any problems at all. Of course, competitors' price is also correlated with price, but again, that's why I created price difference, is just to look at the difference between. That made theoretical sense to me as well, that it would be the difference between us and our competitor's price that would be the driver rather than either one of them individually, which is why I went through doing the computations in the first place. Well, anyway, that's, by the way, you can also look at just the histograms here and see that some of the variables like price difference are fairly normally distributed, sales fairly normally distributed, education looks a little skewed to the right, population and age fairly uniform, income hard to say there, but basically pretty uniform across the thing. And then you can look at these linear relationships here. Of course, you can see price and price difference, a strong correlation, but a lot of the things between explanatory variables are close to flat lines, indicating that there shouldn't be a big problem with multicollinearity. Okay, that's it for this video.